Hello everybody, I'm Hamid Farhai, SR13 from team of 5G. I'm researching on cybersecurity with the help of artificial intelligence, machine learning, and deep learning. In this video, I want to talk about one of the famous datasets that researchers use in the cybersecurity, KDD copy 9099, or the new version NSL-KDD, and we want to discuss about one of the most important issue that before doing any kind of machine learning or deep learning or pre-processing, we need to do it, and that is how to convert our categorical data, categorical feature into the numerical. And we want to discuss about the different type of categorical encoders, and we make some example from the NSL-KDD dataset. If we look at NSL-KDD features, we can see that it contains different kind of features, and here we can see it contains 43 features. According to the resource that you download your dataset, maybe it contains the difficulty level, and for some cases maybe it doesn't contain the difficulty level. So some of NSL-KDD dataset contain 41 features to use as an input and one feature as a target for classification, and some of them contain 42 different features and contain one target for classification. But here we want to speak about these three features: protocol type, service, and flag. These three features are categorical, and we need to find a way to convert this categorical feature to the numerical feature. If we look at the trained data, we can see the number of unique data for the protocol type is 3, and for the service feature, for the trained data, it contains 70 different unique values, and for the flag, it contains 11 unique values. For the target, it contains 23 unique values, and 22 of them is the different type of attacks, and one of them is a normal. That means one of them is a normal data, and the rest is the different kind of attacks. And we can categorize all of these attacks and the normal data into these 5 categories: the DOS attack, normal data, probe attack, R2L, and U2R. That we use the target or target type for the classification. But here we want to, in this video, we want to speak only about the protocol type, service, and flag, these 3 features. Okay, if we look at the test data, the number of unique value in the feature is different. For the protocol type and the flag is the same. Both of them contain the same unique value in train and test. But for the service is different. In the train data, we have 70 unique values for the service feature, and for the test data, the service feature contains 64 unique values. And for doing any kind of pre-processing, any kind of normalization, standardization, using PCA, using categorical to numerical encoder, we only use the data that provided by the trained data, and we don't have any knowledge about the test data, and we shouldn't use any knowledge that is related to the test data. So according to the train data, how many unique value is available for the protocol type? 3. For service is 70. For the flag is 11. If we want to use categorical encoders for converting these 3 category features into the numerical feature, we have different kind of category encoders. Here we list 17 category encoders according to the scikit-learn website. Some of these category encoder is unsupervised and some of them is supervised. What that means? That means for using some of these category encoders, you need to have access the target. You need to have access the labels, the output of each sample, that is normal data or is attack data or any kind of this attack data. And to use those category encoders that need to access the target or the output or the labels, we call they are supervised. And for the other category encoders that don't need to access the target, don't need to access the label, for example, One Hot Encoder that we explain in the next slide, we call it unsupervised category encoder. So here, for example, we want to explain One Hot Encoder because it's very popular and very common to use by the researchers. Before we want to explain about the One Hot Encoder, how it works, so let's see how you can use this encoder. If you don't have this encoder, you can use one of these commands for downloading and installing the category encoders library, and after that you can import them, and then you can define each of them that you want with the specific parameter, and then you use the fit command for the train data. You use X and Y. X, that means the input feature, and the Y is the output feature, and according that your encoder is supervised or is not supervised, is unsupervised, maybe you need to provide Y, or for unsupervised you don't need to provide Y for the fit process. After fitting on the train data, you need to transform on the train and test data. Okay, here we have an example for One Hot Encoder, which is protocol type feature. Protocol type contains 3 unique values: ICMP, TCP, and UDP. So in One Hot Encoder process, we convert each of these unique value into the new numerical features. For example, ICMP here belongs to the protocol type. We use the protocol type underline ICMP, protocol type underline TCP, and UDP. For each sample that the value of the protocol type is equal to ICMP, we put 1 for the ICMP and we put the 0 for the rest. And if the value of protocol type is TCP, we put 1 for TCP and the 0 for the rest. And it's the same for UDP. And in each row, we have only one of them is equal to 1 and the rest is equal to 0. Here you can see another example. For example, here each of this row is one sample and each of this column is a feature. So here we have 1, 2, 3, 4, and 5 samples. We only want to convert, in this example, the protocol type to the numerical. So protocol type, I write it here, and the value for the first sample is TCP, for the second one is UDP, TCP, TCP, and TCP for the rest, and for example for the next one is ICMP. And when we want to convert these samples, these features, only protocol type feature, into the numerical, you can see here, only for here is equal to TCP, we put 1 for TCP, and for the rest we put 0. And here is equal to UDP, you can see here, and we put for UDP 1 and for the rest 0. And for the other sample is the same. Here, for example, the value of protocol type for this sample was ICMP, we put 1 for ICMP and put 0 for the rest. And if you want to do for the other features, for example for the flag or for service feature, you can use the same method. So you can see for the flag, it contains the 11 unique value. So we convert each of these unique values into the new numerical feature. And if our sample, the value of flag feature is equal to, here for example, OTH, we put 1 for OTH and we put 0 for the rest. And according to this table, we create the new numerical feature for the flag feature. Here for One Hot Encoder, we want to see how many new features created after we use One Hot Encoder. Here for train data, you can see for protocol type, we have 3 different unique values for services 70 and for flag 11. And as we told in previous slide, we don't mention this data, this number of unique values in the test data. So we only use the information according to the train data. So for this one, we have, for protocol type, we have 3 new numerical features, for service 70, for flag 11 new numerical feature. And if we sum these 3 numbers, after we apply One Hot Encoder for these 3 category features, we have 84 new numerical features. And here we compare the other encoders. We explain One Hot Encoder that for those 3 category features, it creates 84 new numerical features. And you can see for example, leave one out encoder, if we use leave one out encoder, we have only 3 new numerical features. And for the rest, you can see here. According to use each of those category encoder and then using each of these classifiers or using the deep learning, your result is different. For example, if you want to use SVM in your algorithm for classification and you don't know which one of these category encoder is better for you, use the SVM for comparing the result of each of these encoder. That means use all of this encoder output and after that use the SVM and then according to your result and compare the accuracy, the F1 score, the precision from the train and the test. both of them, decide which one of these is good for your project. Here we make an example for cybersecurity dataset. Maybe for you the dataset is different, but the algorithm and the method is the same. And one of the important things that you need to be careful about it is never use, for example, random forest to compare the result of this encoder and then use another classifier, for example SVM, in your final algorithm for classification. If you use SVM, use SVM for comparing the result. If you use random forest, use the random forest to compare the result of each of these encoders. And don't use, for example, random forest because random forest is very fast. Don't use the random forest to compare the result of each of these output encoders and then pick, for example, one hot encoder because you receive a better result, and instead of using random forest, use the SVM. So it's a right way and you didn't get the good result in your final algorithm. Okay, thank you for watching us. If you like, please subscribe us, Team of 5G and YouTube, and visit us in teamof5g.webs.tsc.uc3m.es.